Hi everyone, I hope you are all fine. Today we are going to learn more about physics, that is waves and oscillations, and please welcome to this session. Our question today says two harmonic oscillations have displacements given by, we have x1 that is given by a1 cos omega t, and then x2 given by a2 cos omega t plus alpha are superposed. So if the two oscillations have a phase difference of pi, show that their combined amplitude is given by a1 minus a2. So this question actually is very simple. So equation number one is very direct. We can call this one equation 1. Let us call this one equation 1 and call this one equation 2. So let us deal with equation 2, because if we solve equation 2, then it means we simply combine it with equation 1. So the solution to this, equation 2 says x2 is equals to a2 cos omega t plus omega t plus phi. So in solving out this one, we have to remember that when cos is into, maybe you have cos a plus p, that is an identity, and therefore this one in our case here, it will simply give us a2 cos omega t, then cos phi, then minus a2 sin omega t sin phi. That is an identity. For example, if you have cos a plus p, you'll be able to obtain cos A cos P minus sin A and sin P. So in applying this one to our question, it becomes very simple. So we're able to find that x2 will be given by a2 cos omega t cos phi, and then minus a2 cos now sin a2 sin omega t sin phi. Yes, we are now at that point. And so now that we have this one cos the a2 cos omega t cos phi minus a2 sin omega t sin phi. Now let us now compare a case where we have a phase difference of phi. So we can simply take a case where that is when phi is equal to pi, and also we can be able to notice what happens here. So when phi is equals to pi, therefore we're able to obtain that x2 will be equal to a2 cos omega t cos pi minus a2 sin omega t sin pi. And therefore up to this point you can be able to say that now we'll be able to look, because we know that pi is 180 degrees, and therefore taking my calculator, sin phi is simply 0, so the other part a2 times that times 0 it is 0. So we're able to obtain that x2 is equal to, simply you can use our calculator here. We can use our calculator here. Cos pi, that is 1 cos 180 degrees is -1. So this one will be able to be negative a2 cos omega t, and therefore the other one sin pi, that is sin 180 is 0, sin 180 is 0, so the other part simply is not there. And therefore, because the waves was proposed, that is to obtain the wave that was formed, it is simply x1 plus x2. So x will be equal to x1, x is equal to x1 plus x2, which will give us x1 was a1 cos omega t, a1 cos omega t. We add it from the equation x1, and then plus x2, that is plus, but remember the second wave is now minus, so plus minus, it will be minus a2 cos omega t. And therefore, up to this point, we can now combine this. We have a1 cos omega t. So cos omega t is common, and therefore we can be able to obtain that a1 minus a2, and then this one, then cos omega t. And remember, when you have an equation like this, a1 minus a2 gives us the amplitude, and the question was show that their combined amplitude is given by a1 minus a2, and therefore up to this point you can say that the combined amplitude, so the combined amplitude, that is amplitude is equal to a1 minus a2. And up to that question, up to that point, we are done with the question. Thank you so much for watching. Please subscribe to this channel.